In the vast cosmic dark, terror can take many forms. Black holes devour light itself. Supernovae obliterate with unimaginable energy. But there's a quieter horror closer to home. A planet once promising, now a hellscape. A stark warning written across our solar system. That planet is Venus. Gazing at Venus from the cold void of space, one can only shudder. What we see is not just a planet, but a reflection. A twisted, nightmarish reflection of what Earth could become. Venus's atmosphere is a chemical nightmare. Carbon dioxide dominates its composition, trapping solar radiation. The surface pressure is crushing, 90 times that of Earth's. And the temperature? A scorching 900 degrees Fahrenheit. The true horror of Venus lies not just in its heat, but in its rain. High above the scorched surface, within the swirling clouds, a sinister alchemy occurs. This is no gentle rain of water, but a corrosive downpour of sulfuric acid. The intense heat vaporizes it before it can land, creating a perpetual deadly haze. As we study Venus, we are forced to confront a chilling question. Is this our planet's fate? A glimpse into a future reshaped by runaway greenhouse effects? The surface of Venus is devoid of life, scoured clean by unrelenting heat and corrosive rain. The silence from this dead world is deafening. We must heed this warning, for as we look at Venus, we confront the fragility of our own world. Imagine stepping onto Venus. The very air would be your executioner. The atmosphere, thick and heavy, would feel like a physical weight pressing down on you. The air on Venus is primarily carbon dioxide, 90 times denser than Earth's. Breathing on Venus would be a futile exercise, inhaling a toxic cocktail of carbon dioxide, nitrogen, and sulfur compounds. Each breath would be a step closer to asphyxiation. Carbon dioxide, the dominant gas in Venus's atmosphere, is a powerful greenhouse gas. It traps heat with ruthless efficiency, turning Venus into a planetary oven. On Earth, carbon dioxide makes up less than 1% of our atmosphere, but on Venus, it's the primary component, accounting for 96%. This trapped heat has driven the surface temperature of Venus to unimaginable extremes. Venus bakes at a scorching 900 degrees. The sheer density of Venus's atmosphere adds another layer of hostility. The pressure at the surface is equivalent to being 3,000 feet beneath the ocean's surface on Earth. Space probes sent to the planet's surface have survived for only a matter of hours. Their metal frames buckle and twist, their delicate instruments crushed under the unrelenting force. Even if we could withstand the heat, the pressure alone would be enough to kill us. The heat on Venus is not just intense, it's relentless. The thick atmosphere traps the sun's heat, creating a runaway greenhouse effect. Day and night, the temperature hovers around 900 degrees Fahrenheit. This extreme heat is a consequence of the dense carbon dioxide atmosphere. Imagine standing in a blast furnace, the air thick with heat and the ground glowing red hot. The intense heat would cook you from the inside out. Observing the surface of Venus is a challenge. The thick atmosphere obscures our view, shrouding the planet in a perpetual haze. But through radar and advanced imaging, we've glimpsed the desolate landscape below. Vast plains of solidified lava stretch for miles, punctuated by towering shield volcanoes and impact craters. The surface is bone dry, devoid of any liquid water. Despite the harsh conditions, there is a strange beauty to this alien landscape. Venus's atmosphere is a cauldron of chemical reactions. High above the scorching surface, a deadly transformation takes place. This is no gentle rain of water, but a corrosive downpour of pure sulfuric acid. The rain never reaches the surface, evaporating long before it can touch the scorching ground. The very air on Venus is thick with sulfur dioxide, a byproduct of the planet's intense volcanic activity. This acid rain is a constant reminder of the unforgiving nature of this alien environment. The formation of sulfuric acid in Venus's atmosphere is a multi-stage process. It begins with sulfur dioxide, ejected into the atmosphere by volcanic eruptions. Ultraviolet radiation from the sun provides the energy for this deadly reaction. The sulfur dioxide reacts with the sparse water vapor present, creating sulfuric acid. This highly corrosive acid condenses around dust particles, forming the acid rain that plagues Venus. The volcanic activity on Venus is a constant reminder of the planet's inner turmoil. Venus is a geologically active world, its surface scarred by countless volcanoes and lava flows. These volcanoes act as giant chimneys, spewing forth gases and molten rock. The sulfur dioxide released by these eruptions is the raw material for Venus's acid rain. On Venus, volcanoes are instruments of destruction, fueling the processes that have rendered this planet uninhabitable. They are a testament to the power of nature, but also a cautionary tale about the delicate balance that sustains life on our own planet. The acid rain on Venus is a phantom menace. It never reaches the ground, evaporating long before it can touch the scorching surface. The intense heat turns the falling acid droplets back into vapor, creating a perpetual haze of sulfuric acid. The sulfuric acid droplets in the atmosphere are highly reflective, scattering sunlight back into space. This high albedo might seem like a good thing, potentially helping to cool the planet. But in the case of Venus, it's too little, too late. The sulfuric acid clouds that blanket Venus are a shroud of destruction. The corrosive power of sulfuric acid is well known, capable of dissolving metals and burning through organic matter. The sulfuric acid in the atmosphere is constantly reacting with the rocks and minerals on the surface, slowly dissolving them. This corrosive process has a profound effect on the planet's geology. Even the spacecraft we send to Venus are not immune to the corrosive power of sulfuric acid. Their instruments and cameras are quickly degraded by the corrosive atmosphere. The scars of Venus's acid rain are etched into the planet's history. Scientists believe that Venus may have once had oceans of liquid water, but the runaway greenhouse effect, fueled in part by sulfuric acid rain, boiled away those oceans. The acid rain played a crucial role in this transformation, a silent killer that helped to sterilize an entire planet. The story of Venus is a cautionary tale, a reminder of the delicate balance that sustains life on Earth. We must be vigilant stewards of our own planet, lest we suffer the same fate as our sister world. Section 1. A Landscape of Dissolution. The surface of Venus is a wasteland shaped by unimaginable forces. Volcanoes, both active and dormant, scar the landscape. Lava flows, frozen in time, stretch for miles. But it's the unseen hand of acid rain that truly defines this alien world. A relentless chemical assault that etches itself onto every rock, every mountain, every canyon. Imagine a landscape sculpted not by wind or water, but by acid. That's Venus. The sulfuric acid rain, though evaporating before it reaches the ground, saturates the lower atmosphere. It reacts with the surface, slowly but surely dissolving the rocks, transforming minerals, and carving a world of desolation. On Earth, we see the effects of acid rain on a smaller scale. Statues crumble, buildings corrode, forests wither. But on Venus, it's the very bedrock that's under attack, a constant reminder of the planet's toxic environment. Every feature, every detail bears the mark of acid. This is not a world where life can find a foothold. The very ground itself is hostile, a testament to the destructive power of unchecked chemical reactions. Even the hardiest microorganisms, those extremophiles that thrive in Earth's most extreme environments, would find no solace on Venus. This is a world where even the rocks themselves are under attack. Mountains on Earth, majestic and enduring, stand as symbols of permanence. On Venus, they are victims of a relentless chemical assault. The sulfuric acid in the atmosphere, ever present, eats away at the rock, slowly grinding down even the mightiest peaks. Imagine a mountain range, once towering and proud, now reduced to rolling hills by the constant rain of acid. That's the fate of mountains on Venus. The acid dissolves the rock, weakening its structure, causing landslides and collapses. Over eons, even the tallest peaks are worn down, their remnants scattered across the desolate plains. This process of erosion is not limited to mountains. Canyons widen, valleys deepen, craters lose their sharp edges. The entire surface of Venus is in a state of constant flux, reshaped by the relentless chemical weathering. It's a slow, agonizing death for a planet's topography. On Earth, we worry about the effects of acid rain on our forests, our lakes, our buildings. But on Venus, it's the very mountains themselves that are under threat, a stark reminder of the power of this corrosive force. And while the timescales are vast, the lesson is clear. Even the mightiest structures are no match for the relentless assault of acid. Though liquid water doesn't exist on Venus's scorching surface, there are rivers of a sort. Not rivers of life-giving water, but rivers of acid. As the sulfuric acid rain evaporates before reaching the ground, it creates a dense, corrosive fog that hugs the surface. This fog, heavier than the surrounding atmosphere, flows downhill, carving channels and gullies in its wake. Imagine a river, not of sparkling water, but of fuming acid, eating its way through the rock, leaving behind a trail of dissolved minerals and a lingering, pungent haze. These acid rivers, though temporary and unseen, leave their mark on the landscape, a testament to the alien nature of Venus's climate. Scientists believe that these acid rivers may play a significant role in shaping the surface of Venus. They can carve new channels, widen existing ones, and transport eroded material across vast distances. It's a slow, relentless process, but over geological time, it can have a profound impact on the planet's topography. On Earth, rivers are often seen as symbols of life, sources of water and transportation. But on Venus, they are harbingers of destruction, reminders of the planet's toxic and unforgiving nature. They are a testament to the fact that even in the absence of liquid water, erosion can still occur, driven by the relentless power of chemistry. One might think that the depths of Venus, far below the scorching surface, would offer some respite from the relentless assault of acid rain. But even here, there is no escape. Scientists believe that the corrosive effects of sulfuric acid penetrate deep into the planet's crust, weakening its structure. The sulfuric acid, carried deep underground by volcanic activity and tectonic forces, weakens the rock. This subsurface corrosion could explain the presence of certain surface features, such as coronae. Venus is a planet under constant chemical attack, both inside and out. Section 5. A planet's minerals transformed. The acid rain on Venus doesn't just erode the landscape, it transforms the very minerals that make up the planet's crust. The sulfuric acid reacts with the rocks, dissolving some minerals and creating new ones, leaving behind a chemical signature unlike anything found on Earth. Imagine a world where the rocks themselves are different, their composition altered by the relentless rain of acid. That's Venus. The sulfuric acid reacts with the minerals in the rocks, dissolving some and leaving behind others. For example, it can transform basalt, a common volcanic rock, into a unique type of clay mineral found only on Venus. This chemical alteration of the surface has profound implications for our understanding of Venus's history. By studying the composition of the rocks, scientists can learn about the planet's past climate, including the role that acid rain has played in shaping its evolution. The minerals on Venus tell a story of a planet transformed by acid. It's a story written in the very fabric of the planet, a testament to the power of chemistry to reshape worlds. And while we are only beginning to decipher this story, one thing is clear. Venus is a planet unlike any other, its unique mineral composition a direct result of its hellish environment. Section 6. A grim warning carved in stone. The desolate landscape of Venus, scarred by volcanoes and etched by acid, is a grim warning. It's a reminder of the fragility of planetary climates. The acid rain on Venus symbolizes a planet gone wrong. Imagine Earth, stripped of its life-giving oceans, its atmosphere choked with carbon dioxide. That's the fate Venus has suffered, a fate that could have befallen Earth. The acid rain on Venus is a stark reminder of planetary interconnectedness. As we explore, lessons from Venus guide us. They remind us to protect our planet's delicate climate. Section 1. A history written in stone. Venus, for all its current fury, holds a hidden past. A past buried beneath layers of volcanic rock etched into the very fabric of its being. Scientists, like cosmic detectives, piece together this history, searching for clues to the planet's dramatic transformation. Their tools, radar imaging, atmospheric analysis, and the study of meteorites blasted from Venus's surface eons ago. Imagine peeling back layers of time, each stratum of rock a page in Venus's geological record. What we find is a story of dramatic change. Evidence suggests that Venus, billions of years ago, may have been a far more hospitable place. A world with oceans of liquid water, possibly even continents and a more temperate climate. The clues are subtle but compelling. Certain minerals detected on Venus's surface, like those found in ancient Martian riverbeds, point to a watery past. The planet's slow rotation rate, unusual for a world so close to its star, hints at a catastrophic event that may have reshaped its entire system. But like a faded photograph, the details of Venus's past are obscured by time and the planet's own relentless geological activity. Yet the search for answers continues, driven by the possibility of uncovering a time when Venus was not a hellish inferno, but a world of promise, perhaps even a twin to our own. Section 2. The faint whisper of lost oceans. The notion of oceans on Venus seems almost inconceivable today. A planet where the surface temperature can melt lead, where the atmosphere is thick with sulfuric acid, seems an unlikely candidate for vast bodies of water. But the evidence, though faint, persists. Scientists believe that Venus may have once harbored oceans, perhaps even more extensive than those on Earth. The clues lie in the ratios of certain isotopes found in Venus's atmosphere. Specifically, the ratio of deuterium to hydrogen, heavier and lighter versions of the same element, can reveal a planet's water history. Venus's ratio suggests a significant loss of water over time, possibly due to a runaway greenhouse effect. Imagine those lost oceans, shimmering under a younger sun, their waves crashing against shores long since vanished. What happened to them? The answer lies in the complex interplay of solar radiation, atmospheric composition, and geological processes. A delicate balance, easily disrupted, as Venus's own history demonstrates. The search for evidence of past oceans on Venus is not just an academic exercise. It's a reminder that planetary climates are not static. They evolve over time, sometimes dramatically. And it highlights the importance of understanding the factors that can drive these changes, both on Venus and on our own planet. Section 3. A Climate Unraveled. The transformation of Venus from a potentially habitable world to the inferno we see today is a stark reminder of the power of runaway climate change. Scientists believe that a series of events, likely triggered by increasing solar radiation as our sun aged, set in motion a chain reaction that ultimately led to Venus's demise. Imagine Venus billions of years ago, its oceans absorbing carbon dioxide from the atmosphere, regulating the planet's temperature. But as the sun grew hotter, more solar radiation reached Venus. This increased heat began to evaporate the oceans, releasing water vapor into the atmosphere. Water vapor is a potent greenhouse gas. As it accumulated in Venus's atmosphere, it trapped more heat, further accelerating the evaporation process. This created a positive feedback loop, a runaway greenhouse effect that spiraled out of control. The increasing temperatures had another devastating consequence. They caused the release of carbon dioxide trapped in the planet's rocks, further intensifying the greenhouse effect. Volcanic eruptions, likely more frequent and intense during this period, added to the atmospheric cocktail of carbon dioxide and sulfur dioxide. The end result? A planet choked by its own atmosphere, its oceans boiled away, its surface scorched by relentless heat. Venus, once a potential paradise, transformed into a cautionary tale of climate change on a planetary scale. Section 4. When Venus Smiled. Despite Venus's hellish present, some hope for a nuanced past. A time when the planet, though hotter than Earth, may have been more forgiving. Life, perhaps in forms we are yet to imagine, could have found a foothold. Imagine life in isolated pockets of water, volcanic vents, or the upper atmosphere. Extremophiles could hold the key to understanding this possibility. These life forms would have adapted to intense heat and a dense, toxic atmosphere. Their biochemistry would be radically different from anything on Earth. Venus's transformation is a story of thresholds crossed, of tipping points beyond which there is no return. Scientists believe Venus may have once supported liquid water. Imagine Venus balanced between a temperate past and a fiery future. Increasing solar radiation and volcanic gases pushed Venus closer to the edge. Then, the tipping point. A massive volcanic eruption or a shift in orbit exposed Venus to more solar radiation. The runaway greenhouse effect took over. Temperatures soared, oceans boiled, and Venus became uninhabitable. Studying Venus's tipping point helps us understand planetary climates and the importance of safeguarding Earth's delicate balance. Venus stands as a silent testament to the fury of a planet gone astray. Baked by temperatures hot enough to melt lead, it serves as a stark warning from the cosmos. This is a world where even the rain is a corrosive acid, where the very air is a suffocating blanket of toxic fumes. The sulfuric acid rain, a product of a runaway greenhouse effect, is a constant reminder of Venus's unforgiving nature. It etches away at the planet's surface, carving a landscape of desolation. The sheer scale of this planetary transformation is awe-inspiring in its destructive power. The extreme temperatures, the crushing atmospheric pressure, the toxic air, and the corrosive rain all conspire to make Venus a hostile and unforgiving place. The most haunting aspect of Venus's story is its silence. No wind whispers through the thick atmosphere, no waves crash against long-vanished shores, no life stirs amidst the desolate landscape. This silence speaks volumes about the planet's fate. It is the silence of a world that may have once held promise, a world that perhaps in its distant past was more like our own. But those possibilities have been erased by the relentless march of climate change. The silence of Venus is a stark reminder of the fragility of life. The stark contrast between Venus and Earth highlights the fragile thread upon which life hangs. On Earth, we are blessed with a temperate climate, liquid water, and an atmosphere that sustains us. But Venus serves as a constant reminder that such blessings are not guaranteed. The key to Earth's habitability lies in a delicate balance. Our planet's distance from the sun, the tilt of its axis, and the presence of a magnetic field have allowed life to flourish. Venus serves as a cautionary tale, a reminder that small changes can have catastrophic consequences. The runaway greenhouse effect on Venus is a stark reminder that Earth's balance is not inviolable. The fragile thread of life underscores the importance of understanding planetary climates. We must be vigilant stewards of our planet, protecting the delicate balance that sustains us. Though a world of fire and acid, Venus offers profound lessons for humanity. It stands as a stark warning against unchecked industrial activities. The runaway greenhouse effect on Venus shows the dangers of ignoring our planet's health. The lessons from Venus extend beyond climate change. Its toxic atmosphere highlights the interconnectedness of planetary systems. What happens in one part of the system can affect the entire planet. Venus also underscores the importance of planetary exploration. By studying other worlds, we understand our own better. The lessons from Venus call us to action. We must act now, while there is still time. As we gaze upon the fiery, unforgiving landscape of Venus, we are forced to confront a fundamental question: what will be the legacy of humanity? Will we be remembered as the generation that squandered its inheritance, that pushed our planet beyond its limits in pursuit of short-term gain? Or will we rise to the challenge, learn from the mistakes of the past, and become the generation that steered Earth towards a brighter future? The choice is ours to make. We can choose to continue down a path of unsustainable consumption, of disregard for the environment, or we can choose a different path, one that recognizes the interconnectedness of all things, the delicate balance of nature. The path forward will not be easy. It will require courage, sacrifice, and a fundamental shift in our values. It will require global cooperation, technological innovation, and a willingness to make difficult choices. But the alternative, the path that leads to a future resembling the hellish landscape of Venus, is simply unacceptable. We owe it to ourselves, to future generations, and to the countless other life forms that share this planet to make the right choice. The legacy of humanity is not yet written. The future is not predetermined. We have the power to shape our destiny, to choose a path that leads to a sustainable and thriving future for all. Let us choose wisely, for the sake of our planet, and for the sake of all those who will come after us. The time for action is now. The choice is ours. What will be our legacy?